Hi, this is Tina, Senior Manager of Corp.北尔Electronics. Welcome to our webinar today. Today, our topic is Building Corporate Resilience with Comprehensive Digital Transformation in Manufacturing and Environment. The traditional architecture is divided into three layers: device layer, control layer, and information layers. It's like a pyramid, and data is delivered layer by layer. In a traditional factory, this is not a problem. However, the digitalization is requested by the managers and controlled by the IT department. It is necessary to streamline the stack structures for following reasons: because the data for the traditional structure is not running in real time. The data is not transparent, and the data volume is not big enough. So when it comes to the digitalizations, we need to have a tool to help to streamline the stack structures. And this tool is a smart machine. There are some key strengths of the smart machine that can help to solve the problem. The first one, the smart machine can help to have real-time communications. And the data is transparent being delivered. And then the big data volume is available. Also, it's presented in multiple ways, and then it's easy to be expanded. Next, we are going to talk about how the smart machine helped to streamline the stack structure. Earlier this year, we have been talking about the first step for the digitalization is data collecting. We need to have all the data being collected, communicate, and integrate. And then the smart machine is the key for this one. And however, for the OT to do the digitalization, there are some problems that they are facing. The first one is that there are a lot of old controllers that they are not able to collect data. And then the second one is there are various of the controllers, and either in brands or type, that makes the integration of OT data very confused. And then the third one is that even that you have the data being collected, you have the controller can be collected. However, you don't have the source code of the controllers, you are not able to do that. And then for some machines that you want to collect data from the machine, however, you cannot just easily get the data from the machine because there are warranties of the machine. You cannot break the machine and just collect data. Or sometimes the machine builder is not willing to provide data for you. And then there's a know-how for the OT and IT are different, which makes the communication is difficult. And then the last one is that for semiconductor industry, they have their own SSGen protocols, which is not common to be used. And then what is Corp.'s smart machine can help you? First of all, Corp.'s smart machine covers 95% of the PLC drivers, even that for very old controllers that we still have the drivers available for data collections. And then the second one is that we only figure the protocol type, no matter which brand, which type of controllers that you are using. As long as the protocol is supported by us, that we can help you to collect data. And then the third one is that even that you don't have the source code of the old driver or old controllers, that we still can help to collect data because like we mentioned earlier that we cover 95% of the drivers. As long as there's connectors available for us to collect data, that we can help you collect data. And then the first one is for the machine. We don't need to break the machine or change the machine controllers. As long as you have the connector that we can have the driver support, the machine data can also be collected. The fifth is that we have the OT and IT protocols available. So you don't have to worry about that. You have to one software for OT and one software for ITs. It's all inside our smart machine. And then we also can add the SSGen drivers that no matter what controller that you are using in the OT side, as long as we collect the data, we can change that to the SSGen protocols and deliver data to the IT, semiconductor IT departments. As we mentioned earlier that we already collect data from OT, and then next we're going to use this data and make this data into informations. That is the real goal for the digitalizations. Well, and there are three most common applications that IT department do when they collect data from OT. The first one is visualizations. Data are numbers, which is difficult to understand. If you can have this data into visualization, even a chain chart, that will be easier for the operators or manager to read what's going on in the factories. And then the second one is to collect data to MES and ERP systems. You want to have a smart scheduling, smart manufacturing, then you need to have interactions with all these MES and ERP systems that make your data being useful. And then the third one is that you can have this data being delivered to, say, third-party AI modules. Some AI modules from third parties that help you to improve your production efficiencies. But doing all these common applications, there's some common rules that you have to know is that you need to have protocols being able to communicate to all these different systems. This system might not exist just once. They might have to multiple presented ways. So what Bear's Smart Machine can help you? First of all, we have visualization inside. We have all these drawings, train charts inside the system. So you can just easily have your data change into visualizations. And then the second one that we have support RESTful API, MQTT, OPC UA, and Modbus. So you can easily deliver your data to like third-party AI edge servers, MES, ERP system. All these protocols are supported inside. And then we also support session communication protocols in our smart machine. And then with all this software, it's all together. No matter it's IT side or it's OT side, it's just one software, and it's very easy for customer to use. And now we have all these big volumes of data. What else can we do? How can we improve the performance of the company? Well, we can also still do the efficiency optimizations. This is more related to the factory size. We can have the machine health condition diagnostic. We can have the operation quality efficiency optimizations. And then with the data transparent in this side, we can have the risk control and management because all these data are transparency. And you also integrate with a lot of different systems. So that you can easily have transparent data for manager to make good decisions. And then we can you can have data or information cross-department integrated, and you can lower the risk during your operations. And then as we mentioned earlier this year, that there are also requests of ESG. This is the world trend that you have to follow the ESG regulations. So if you can have a lot of data transparent, you can also meet with government's regulations or ESG change. And then between all these requirements, which one is most easy to adapt? Well, we can easily do the machine health condition diagnostic and operational quality efficiency optimizations. And how do we do that? We're going to introduce you to later. Let us use the semiconductor example to understand the efficiency optimizations. First of all, the semiconductor is a very high-tech manufacturing. Because even though that is high-tech, it's not 100% yield rate. However, because it's a very expensive product, a little failure that can cost a lot of cost to the factories. So continue improve the yield rate is still a target for the semiconductor industry. And then how can we do that? Well, first of all, you have to main process control. For example, the main process control for the semiconductor industry will be the wafer equipment. Okay, wafer equipment manufacturing wafers. However, there are some still surrounding equipment such as dry pump, chillers, compressors. For the wafer equipment to deliver good quality product, it needs to have a vacuum environment. And these dry pump, chiller, compressors help to provide a vacuum environment for the wafer equipment. So we need to monitor both the main process control and an optimize of productional environment. With all this together, you can have your efficiency optimizations. So focus on the environment control this one. You need to have the operational quality and health of the equipment that will impact the main process environment, main process of productions. So we need to monitor the dry pump, the chiller, the compressor, and gas, etc. So what can we get from these machines? So we can see is that for dry pump chillers that we also have to do the machine health condition diagnostic. And you can easily to get data, for example, temperature, humidities, horsepower, rating current. This data are already inside the machine, or you can get from while it's operating. But it's just never being paid attention. It was there. It's either that you turn on the machine, you can collect the operational data, or the settings inside the machine, or you can get from the user manuals. And all this data actually were there all the time. But in the past, nobody paid attention to that. But now, when we have to monitor the main process, also the environmental qualities, that we also have to check the health condition of this surrounding equipment. Once you get the data, what can we do next? Well, if we have all this data together and it was there, no additional cost that is needed. You just use mathematical algorithm to combine machine data to come out correlations. Okay, just figure out the relationship between all these data, and then you use the mathematical ways to do that. You don't have to do the AI learning. You can execute it immediately. And then once you have the mathematical algorithm available, you just monitor this mathematical algorithms. If there's any abnormal comes out, that you just raise your hand, send out an alarm just to check out what's going on. Even though you don't know what is exactly going on, but at least you know there's an alarm comes for you. All right? For example, let us use a car as an example. Okay, if you drive a car, and then in the old time that you feel something's wrong with your car, it's just even not work, you have to make sure you drive your car to the dealer, to the manufacturer side, and then ask them to check. And then the engineer just bring a computer and check out what's going on inside your car, and then they can fix that immediately. But now we have the monitor on the car. It is similar to a smart machine for the car, that you can see what's going on. There's an alarm shows you that something's wrong with this car. Even though it's still operating, but something's wrong, there's an alarm comes for you. Then you can earlier to drive your car to the manufacturing site to check what's going on. Even that, so it's just like it's always there. Like we mentioned, that all this data, all this alarm is already inside the car. Like in the old time and in right now, it's all there. You don't have to spend any additional cost. It's just that in the past, it's not showing to you. But now, if you can monitor the data from the car, then you can have a pre-action to protect your car, which means to protect your drive safety. All right? Is there any other ways that we can do also to monitor the quality of the surrounding environment? Of course, there are. However, we have to, in the old time that you just use the regular annual repairing, all right? In the old time that every year, by the end of the year, you just shut down all the factories and just do the inspection of all the machines. Even that is still operating well, but there's some components that usually easily out of control. So at the end of the year, you just change a component. No matter it is okay or not, you just change it. And then it's cost effective. It's very costly because sometimes the component is fine, but you just worry that it might break in the future. And it's usually broken. This is the component that usually causes problem. You just change it. However, it's a waste of money. Sometimes it's just operating well. And then you also have to stop your factory just to do the inspection. It's very it's not cost-effective solutions. And then there also The other way is that people install the sensor to monitor the equipment operations. However, for this surrounding environment, sometimes they're just not very expensive. However, sensor is very expensive. You install the sensor and each bearing costs you 2 sensors. If there's a couple bearings inside, the money that you spend on the sensor might be higher than the equipment itself. And then using the sensor, you just monitor the bearing. What about other components? There are still some other components that you're not able to understand what's going on. And then it's just cost effective, and it's just cost money. And then besides that, you need time to building a modeling, and then it takes time. So both of them are not very efficient way to monitor the status of the equipments. So basically, we still suggest that if you can collect production and equipment operating information, it's just real time. You just collect data, so you don't need to do anything, all right? And then it's plugin that you can use. You can have the data immediately. You don't need to take time to do the modelings. And then you can connect them to all these different systems, and then it's just a real digitalization. Also, it's lower cost because you don't need to install a sensor. You don't need to shut down the whole computer. You don't need to throw out the components that you wonder that they might running out of control in the future. So basically, if you can monitor the main process, also the environmental equipment, it is a much more efficiency optimizations for the factories. Next, we're going to show you some cases about how our customers do to enhance their quality, production qualities. This is the case that our customers that have all these manufacturing stations individually, and then they have our smart machine being installed with each stations, and then collect also the controller's data, also the operation informations. And then with this data being collected, they were sending to the edge servers, and then each server has the AI modules that they purchase from outside, and then doing the quality management. Also collect all this operation data, environmental data to do the analysis by themselves. And then at the same time, this data are being also sent to the MES and ERP systems. And then also the other way, they send to the SCADA stations. So like we mentioned earlier, they might not work independently. Sometimes they just have all this data collect and then go to different purpose, go to different directions. And this is the case from traditional manufacturing. And then this is the case for the semiconductor industry. For this case, that we have 12 brands of dry pump in the bottoms, and this is a huge fab. So we need to collect all this dry pump data, and these dry pumps do not support SASGEN protocols. So basically, first of all, we collect data for different brands of dry pumps, and then to our smart machine. And then in our smart machine, we also translate all these dry pump protocols into SASGEN protocols. And then once we transfer successfully, we use the 5G routers to wireless deliver this data to also the SCADA station, also the MES stations. So this is the case that we first get involved with the semiconductor industry, and then they also collect all this dry pump data to make sure that dry pumps are operating very well, providing a good working environment for the warfare equipment, and then to better enhance their yield rates. And then after this case, that customers start to realize the benefit of monitor this surrounding equipment data. So this is another bigger scope cases is that besides dry pump, they also start to monitor the gas, the chiller, the compressor, the HVAC environmental data. And then at the same time, they also monitor the scrubber systems that to make sure all these surrounding environments are working very well, and then can lead to a very good yield rate of the warfare equipment delivered products. Thanks for joining our webinar. Hope our case to help you understand it is not only important to monitor the main equipment, also the surrounded equipments. Thank you.